let's get started. So first of all, my name is Ciel Vaughan. I work with Share Screen Africa and I'll be the host of today's event. I'd like to welcome everyone back to this NaDEET series, which is we're doing in collaboration, and it's titled Exploring Biodiversity and Climate Change to Enhance Teaching and Learning in Namibia. And it's particularly tailored for the NaDEET teachers in training, who will then bring this awareness into their classrooms. The last talk for this series was just after 3.5 months ago, so we're really eager to jump back into it and get started, and we've got a great lineup of more speakers to come, including today. I'd like to acknowledge and thank Alyssa Volkman, Panduleni Handango, and Victoria Kedding for the co-creation of this series of talks. And for those of you that are new to the series, just a little bit of an introduction. NaDEET addresses the relevant environmental issues through hands-on experiential learning and supporting the Namibian school curricula in a practical and learner-centered way. And us as Share Screen, we introduce experts from all over Africa to audiences through creating these virtual classrooms over Zoom, such as we're doing now, on topics that are of interest and value to them. And now I'd like to focus on our speaker today, Kathy Drummond. Kathy, thank you so much for agreeing to speak for us today. Just a little bit of background on Kathy. She grew up with a strong exposure to wildlife and nature, visiting places like the Kruger National Park and reserves in the Mahalisburg Mountains. She studied nature conservation and has an experience in environmental and marine education, reserve management, conservation training, and developing community conservation areas. Kathy's also involved in coastal rehabilitation projects, and she enjoys recreational diving and training and competing with her dogs. So thank you so much, Kathy, and the floor is yours.
Thank you very much, and thank you for inviting me to come and present today on a topic that is very close to my heart, which is the value of our oceans. So I work for an organization known as SAMRA, which is the South African Association for Marine Biological Research. And we're a non-profit, non-governmental organization, and we have 3 different legs that make up the organization. The first is the Oceanographic Research Institute, which is our scientific arm. And there we have fisheries and marine scientists working on various projects in collaboration with governments and other organizations, universities in the West Indian Ocean, as well as around the coast of South Africa and up into Africa. And we have our aquarium, Shaka SeaWorld, which we use as an outreach program. It reaches out, we have guests and visitors coming in to have a look at animals that are found, fish, marine invertebrates that are found around the coastline of Southern Africa, but focusing mainly on the West Indian Ocean and the marine fish, tropical fish that we find off our shores on our rocky reefs and coral reefs. In that section, we also have all the people who are responsible for the animal care, welfare, as well as the technicians that are responsible for maintaining our water supplies and all the rest of that. And then last but not least, and I think the most important, is our education side, which takes what we get from the scientists and what we have available on site at the aquarium, and we interpret for our guests that come to the aquarium, as well as for school groups that come through. And we have a very large outreach program. So we have schools coming in that wouldn't ordinarily be able to come and visit us. And they come through and they are able to experience and see some of what is found within the ocean. Anyway, most importantly, let's get on to the topic. And the Earth is a planet that has all 3 states of matter. It's got gas in the atmosphere. It has solid ground, the lithosphere, liquid, being the water, making up the hydrosphere. Approximately 70% of the ocean or the Earth's surface is covered by water. And this gives it the title, the blue planet, when you look at it from space. But before we look at the ocean in more detail, let's recap one of the more important ecological processes that occur to enable life across the globe, and that's the water cycle. As we look at the slide, there is one very important fact that stands out, and that is most of the water, which is a very limited resource, is stored in the oceans. As I go through this presentation, I'll be highlighting the importance of the oceans to us as well as what we are doing to the oceans. So we need to start right from the very beginning. 150 million years ago, when the planet as we know it looked vastly different to today, this was known as Gondwana land. As you can see, it's a solid land mass surrounded by an ocean. As the tectonic plates started drifting and moving, this single landmass broke apart, and the continents started taking shape. And as that change took place, the ocean was also divided and gave rise to what we have today. And this movement then also brought about large changes to what was happening in the ocean. So as the Earth rotates on its axis, there is friction between the surface, the liquid and solid matter, and the atmosphere. And the equator, being the widest point of the Earth perpendicular to the poles, experiences the greatest amount of friction over distance. Okay, this transfers energy to the liquid, resulting in movement of the water surface in the opposite direction to rotation. And the result of this is current, or surface current. Previously, when we had no land masses to obstruct the movement of this water, it flowed pretty much unimpeded around the globe. With the rise of the continents, this current now had obstacles in its path, which deflected the flow, resulting in the formation of surface currents in both hemispheres between the continents. So these currents, or gyres as they are known, contribute to the climate of the countries along whose coastlines they flow. So let's take a quick simplified look at how that happens. As the water flows along the equator, or the equatorial region, it heats up. That warm water then flows along the east coasts of the continent, or the continents. As it hits against it, it's diverted or deflected to the north or to the south, and flows down those or along those east coasts, bringing with it warm, moist air that results in tropical and temperate conditions with hot, wet summers and warm, dry winters. As that warm current moves further south or northwards, and it reaches the cold polar regions where that water is then cooled down, it gets pulled back up, because remember that at the equator, the water is being pushed away, leaving a space, an empty space. But with water being liquid, obviously it can't pile up, and something has to replace it. And that warm water is replaced by cold water coming up from the polar region. So every single continent's west coast has cold water flowing along the west coast up towards the equator. And this gradually warms as it moves closer to the equator. What impact that has on the climate in those areas is that instead of having hot, wet summers on the west coast, you have dry summers. And instead of having dry, warm winters, you've got very cold, wet winters. If we have a look at this, we can see the temperature, the surface temperature across the globe. And across the equatorial regions, we can see that it's the hottest, and the coldest areas are at the north and the south poles. And this is due to the angle of the radiation from the sun. Now, if that stayed as it was, we would be boiling. We would be beyond boiling along the equatorial, tropical, and subtropical regions. And the polar regions would be even more cold than they are. This doesn't happen because of one very important current: the ocean conveyor belts. So not only do we have the surface currents going around, or the gyres between all the continents, but we also have this one which links all the oceans together, and it helps to distribute heat and nutrients around the oceans. So as the warm water on the surface gets pulled around and gets pulled up towards the colder regions, that water cools down. Cold, salty water is more dense than warm water. So as it cools down, it sinks. And as it sinks, it's pulling that warm water up to replace it, cools down, and it gets pushed around where it collects nutrients, and it get brought back up to the surface as the water warms up, as it reaches the more temperate and equatorial regions. And so it moves around slowly, distributing the heat and nutrients around. And it's this current, this deep sea current, that makes the Earth habitable. It stops that buildup of intense heat along the equatorial region, and it stops the intense cold from the polar regions. And it is what stabilizes our climates and makes the Earth habitable. If we have a look at productivity now around the Earth, we know that the globe, or the equatorial regions on land, are the most productive because it's more heat, more warmth, seeds germinate better productivity there, more nutrients available in the soil, and so on. But in the ocean, if you have a look at this, the dark blue areas are the areas where there is no productivity, no photosynthesis taking place. And the lighter green to yellow areas in the ocean are where we have high levels of photosynthesis taking place. So warm water equals less productivity. Cold water is greater productivity because there's more oxygen and more nutrients available in the water to allow this to happen. Because of all the surface currents and everything like that going on, the east coasts of the continents having warm water are less productive, but they are high in biodiversity because of the temperature. Animals don't have to focus their energy on surviving, but can focus on breeding and being nice and bright and colorful, and lots of different ones, species can be found. Whereas on the west coast, with the much colder water, a lot more emphasis is put on survival, but there's more food available. So the animals that we find there are fewer in diversity, but we have much more. So we have high biomass on the west coast of all the countries. And this is driven by the currents that we saw earlier. And you can see going up the west coast, the bright green areas, that's the productivity along there, and then it gets dragged across the equatorial region by that current that flows across there. And very, very thin areas of productivity along or down the east coasts. Right. So that's the whole global area, but we're very interested in what's happening around Southern Africa. So around Southern Africa, down the east coast, we have the warm Orgullis current, which is a very fast-flowing and very stable current, which comes down through past Mozambique, down around the south coast, the southern Cape coastline, and some of it will move up past the Cape and in towards the Atlantic Ocean. And we have coming from the south up the west coast, the Benguela current, bringing in cold, nutrient-rich water along the west coast, which is what makes it the very rich fishing grounds. Interestingly enough, along the Namibian coastline in the north, you have the Angolan current, which is warm water that bridges in and wedges between the cold Benguela current and the coastline. And it helps push that colder water away and is part of the whole process that allows for this very rich area with upwelling taking place along the southern Namibian coastline and the northern South African coastline. And that is where most of the productive fishing grounds are. So along all the coastlines, we find different environments, and each one of these environments has specific plants and animals occurring in them. And I'm going to just briefly take you through each of these different environments and highlight the types of animals and the adaptations for each. So we start off with the sandy beaches. Okay, these are sand, no rocks, very bare, good for tourists, love sandy beaches. It's nice for recreation, but they're dealing with wave action. They're dealing with tidal change. And if you have a look at the sandy beach, there's nowhere for animals to hide. There's nowhere for plants to attach themselves to. So you'll find that those plants and the animals that are found there are single cellular algae. They are animals that can burrow, live in the sand, and escape from the wave action, be able to move up and down as the tides change, and cope with all of that movement, with the sand being moved, beach erosion, and the beach being built up again. The rocky shores are also exposed to that tidal and wave action. And the types of animals we find there, though, are animals that have a substrate to attach themselves to. There are cracks and crevices to hide away in. There's substrate for seaweeds and algae to attach themselves to. So you have a much greater diversity. In fact, places like your rocky shores and your rocky reef and coral reefs are mini hotspots of biodiversity. Okay. The animals that we find here, if they're stuck on the rocks, they either have shells to protect themselves, they can close themselves up and make sure that they are don't dry out during low tide. At high tide, they will open up their filter feeders if they can't move, so that they can filter the food, the plankton, out the water as it gets washed over them. Or if they, in the case of anemones and some of the soft-bodied invertebrates, they close up into polyps to stop themselves from desiccating or drying out. And then when the tide comes in again, they're then able to catch food that gets washed in and carry on with life. Rocky shores are also very important areas for young nursery areas. They provide protection and they provide a lot of nutrients for small fish and other animals to start off life. Estuaries, which are the place where rivers and fresh water meets the sea. And in this environment, we don't have wave action like we do on the sandy shore and the rocky shore, but we have tidal influences. And when the tide is high, we have salt water encroaching up into the river, into the estuary, and at low tide, it's predominantly fresh water. With those changes, the types of plants and animals that we find in there have to be able to cope with the changes in salinity. So you'll find certain plants will only be found in certain areas up and down the estuary, or up the estuary away from the salt water, as they can't tolerate higher levels of salinity. Estuaries are very important breeding grounds or spawning grounds and nurseries for small fish and other animals. They're highly rich in nutrients because they don't only get nutrients being washed down by the rivers, but they also have nutrients being brought in by the sea during the high tide. And this allows for this really rich place, this very important area for breeding and nursery development to take place. In some estuaries, we find mangrove swamps. Now, mangroves are a highly specialized type of swamp. And interestingly, Africa has 20% of the global mangroves. Of that, 76% of those are found on the west coast of Africa and 24% found on the east coast. The mangroves found on the west coast are mainly found around the bulge of Africa, where we have a lot of rivers coming in and we have a highly productive, lot of estuaries and highly productive areas. So again, as in our estuaries, it's an environment that's influenced by the tides. And these trees are growing in a very saturated environment. So plants cannot survive if the ground they're in is constantly flooded, unless they have certain adaptations. So the mangroves are highly specialized to survive in this kind of environment because they have specialized roots that extend above the level of the ground up into the air so that they can obtain oxygen and don't drown. And these roots are called pneumatophores. And it's one of the ways you can identify the different types of mangroves by looking at the types of roots, pneumatophore roots they have. The food chain, so most of the life starts in the mangroves on feeding on detritus. It's the most common source of food for these animals. And you mainly have crabs, snails, and other invertebrates like prawns and shrimp that you find living in the mangroves, along with certain fish and birds. Mangroves also offer a very important buffer between storm surges and stormy seas against what is inland from them. They slow down and they break the force of the water and allow what is occurring or what is living behind the mangroves to have a less impact than they would if those mangroves weren't there. To the extent that a lot of island countries that had destroyed mangroves to meet the tourism development pressure are now rehabilitating those areas and reintroducing mangroves so that they can take back that role. Then we have the open water, and this is middle of the ocean. Remember, if you think back to the slide with the productivity, you know that the center of the ocean has very little productivity taking place there. So unlike how people used to think way back that the sea was this huge cornucopia of fish and food and everything else, in reality, that's not the case. A lot of the fish and the life is around the edges of the large oceans and not so much in the middle. The open water consists, or generally the types of animals you find in there are drifters and plankton, animals that rely on wind and current to move around, and fast swimming fish, your game fish and schooling fish that are able to then prey on the animals, the fish feeding on the plankton. Then we have rocky reefs. Now these have a substrate, a hard substrate, the rocks, which allow animals and to be able to attach themselves to and live on, such as sponges, corals, invertebrates, and obviously fish that will live around there and make use of them. And also they're a highly productive area, providing safe spawning and nursery places for the juveniles of these animals to grow. The rocks, depending on the depth, also provide a surface for the growth of algae and seaweeds. And this assists in creating many biodiversity hotspots. Coral reefs are another one. And up until recently, people thought that you only found coral reefs in the warm tropical waters because they were inhabited by tropical fish, bright, colorful animals, a blissful environment. Until quite recently, when I say recently, it's about 10 years ago now, where they discovered that there were much deeper rocky or coral reefs. And so we have subsequently realized and doing a lot of research on deep water corals. So these are animals that can deal with much colder environment. And where in areas where we thought we didn't find corals, we now are thinking twice about that and are investing more in research because those coral reefs require more protection. So they play a very important role in ensuring that the oceans remain healthy. Within coral reefs or within corals, these are little animals. We have soft corals and we have hard corals that have a calcium carbonate structure in which each little coral polyp lives. But the corals have an algae. They've got a symbiotic relationship with an algae called zooxanthellae algae. And corals are tiny animals. And for them to be able to catch or filter out enough food in the water would be very difficult for them. So they rely on the zooxanthellae algae to photosynthesize and provide them with food. Now, with global warming and climate, well, global warming specifically and increasing sea temperatures, these zooxanthellae algae become overactive. And if you have young children and their friends come over or young nieces and nephews and you're dealing with them and all their family, when they're highly overexcited, it gets to a point you can only take so much, and then you just want to kick them out so that you can have some peace. So literally that's what happens to the corals. They get tired and frustrated with this overactive zooxanthellae algae, and they expel them. When that happens, they lose a source of food because now they no longer have as many zooxanthellae algae photosynthesizing and providing them with food. And when that happens, we call that coral bleaching. Right. If the water temperature remains hot or warm, increased for a long period of time, once there's a certain point of no return where these zooxanthellae algae can no longer or will no longer be reaccepted in to the corals, and at that point the coral then starts dying. So this is something that a lot of research is going into to see where that point of no return is as well, and to see how long corals can survive outside of their temperature range before the zooxanthellae algae are no longer accepted back in. And then we have our sandy bottom, right? And the types of animals we find here are our detritivores, such as some of our invertebrates, such as sea cucumbers, sea stars, and then animals like the bottom-dwelling fish and rays that will feed on animals that are feeding on the detritus. And being deep sea, these areas don't suffer that much at all from the wave action or tidal rain changes in tide, but they are impacted on through other uses or other activities that take place within the ocean. So now we've got a little more knowledge about the complex systems that the oceans really are. And I want to now take you through to have a look at what they provide us and what we are doing to them or to the ocean. Oceans are very important places for us as humans. They provide us with an area for sports and recreation. We can go fishing, there's boating, diving, swimming, relaxing, getting back to nature. Very important part of human nature to be able to have a place where you can relax, and that is a natural area. We can only take so much of the humdrum of city life before we actually need to get away, take a break, and get back to basics. Obviously, the oceans are extremely important economically. And as I've already mentioned, up the West Coast, one of the largest sources of or parts of the economy is the fishing. Being highly productive, large biomass. So we have our fishing industry, but it's not restricted to the fishing industry. If the fishing industry were to collapse, it's not just the boats and the fishermen going out to catch the fish that are affected. It's also everybody who's within the support industries. So that would be the processing plants, that would be the tin and can manufacturers, the packaging manufacturers, the transport of moving the processed fish around, that would all be impacted on. So it's not just as simple as all of that. Then, of course, we have up the West Coast, we've got the mining of alluvial diamonds. We've got minerals that are being mined from the bottom of the ocean, as well as oil and gas. Transport. The oceans are a highway for transporting people around the world, enjoying themselves on cruises, or transporting goods on ships to raw materials, processed materials around the world to support industry. Obviously, we have, if you ever, I should have actually included a slide showing some of the fishing lanes around the Southern Africa. And when you realize how many ships are actually out there in the sea, it's quite frightening. when you see it, it's like, and all these ships have an impact on the ocean. They have are moving around with water ballast, and they're pumping in water from one area and moving to another part of the globe, and they're discharging that water ballast. So that's one of the threats one of the things I'll talk about a little later when we look at some of the threats our ocean faces. Harbors are an important part of that whole transport industry and transport hub. Now, along the Southern African coastline, there are very few natural harbors. Most of the coastline is very linear, and any natural harbors there are usually estuaries that are then developed, and habitats are changed to allow for the harbors, the engineering in the harbors, for these ships to come in. The bottoms are dredged up and the sand is taken elsewhere, destroying that all the layering on the substrate down there. So habitats are either changed or they're destroyed to allow harbors to operate and to develop to handle increased shipping as populations grow. And the transport of alien invasives in the water ballast, or as fouling on the keels of the vessels, impact on our indigenous species and can create huge problems when it comes to food provision and food security from our oceans. Looking briefly at some of the threats that we have, that the oceans face, the biggest and, well, one of the largest is climate change. And this, with increasing global temperatures resulting in warmer or warming sea surface temperatures, the impact of that warming water affects the distribution of fish. Remember, our richest fishing grounds are where we have cold water. So as that water warms up, so we're going to find that we'll have lower productivity, lower biomass, and the fishing will move, either the fish will move away or they'll die out. We also, with all of this, have an increase then of ocean acidification, and the result of this is then thinner shells on our shelled mollusks, of the carapaces of our crustaceans, the crabs and the lobster and prawn that we would be fishing, harvesting. Animals like our corals, especially the hard corals, their calcium carbonate structure that they rely on for support and for growth, will disintegrate. It will dissolve with the increase in the ocean, with the acidification of the ocean. And all of this makes them more vulnerable to predation. Pollution. One of the most visible threats that there is to the ocean, and invisible threats to the ocean. Now, the big thing to remember about pollution and plastic pollution especially is it does not break down. It breaks up into smaller pieces. And as soon as it starts, when it's breaking up into smaller pieces, it is then available in the sea. It's ingested by plankton, which in turn is ingested by fish. And through there, it's made its way up the food chain, and we are eating microplastics or nanoplastics. And the scariest thing of it all is that they are finding nanoplastics in the muscles of fish and animal marine life that we eat. So that's making its way into our bloodstreams and into our muscles as well. So but it's also something that's quite easily or can be remedied or reduced. And the big thing, though, with pollution is the water cycle assists in bringing the pollution from inland down to the coast. It's not just a problem in the coast, and it's not just coastal pollution that affects the oceans. It's pollution from up inland, where it gets blown, it gets distributed, transported by wind or by water down to the oceans, and has this impact on it. Then there's overfishing. With the increasing population and fish being a staple diet for a lot of people, we need to supply more and more fish. There's a demand for more and more fish. And if we don't manage our fisheries adequately, and make sure that the methods we're using are more specific and that we put things in place to reduce bycatch, which is what is unwanted. It's not the targeted fish. That in this way, we can make sure that our fisheries become sustainable.
Hi, Kathy.
Hi, yes.
Sorry, it seems that your sound has dropped off. You've just gone completely silent on my side.
Oh, okay. Is
Oh,
that better?
yeah, there we go. It's back. Maybe it was just my internet on my side. Sorry, carry on.
No problem at all. Okay, so then with the overfishing, we have that we need to become more aware as consumers what is happening, where we're getting our food from, where it's sourced. And something I didn't put up on the slide, which is also a huge threat to the oceans, is habitat destruction. So people are destroying coastal dune areas. Dunes are very important. They're an important buffer to the ocean. And they're an important sump, a storage area for sand. So if you have high storms and large seas and a lot of erosion taking place, those dunes actually ensure that the beach can be properly stabilized again, that it can build back up to where it was. If you remove and bulldoze those dunes, like a lot of people like to do because they want to have their beach house with a 180-degree sea view, you're then setting yourself up for one day going to sleep with a lovely sea view and waking up in the sea. Because those dunes are there for a reason. So habitat destruction, not just on the actual shoreline, but out at sea is also a huge problem. Trawlers, ground or bottom trawlers looking for your bottom fish are dragged across the seabed and they just pick up everything that is down there. Rocks, corals, seaweed, turtles, shark eggs, whatever's down there gets picked up in these large trawl nets. But the targeted fish is only a small part of what gets trawled. And the damage to that is evident for years and years. Okay, and it takes a very long time for it to recover from things like that. So what can we do then to make sure that we protect areas along our coastline and in our ocean, the areas of the ocean that we're responsible for or we can do something about? So one of the things that can be put in place to mitigate some of these impacts, other than reducing our carbon footprints and being careful which fish we consume by finding out where it comes from, what fishing method is used, is marine protected areas. Marine protected areas don't only provide protection of a sensitive environment and important habitats, but also spawning sites and nursery areas. They also help improve livelihoods for people living around the marine protected area. So one of the ways this happens is that within the marine protected area, fish and animals are not targeted. They are left in peace to carry on and breed and behave the way they would normally behave. And as their numbers increase, they run out of space and they spill out into the areas adjacent to the marine protected area. And by doing that, they then make themselves available to be harvested by communities, by people, by industry outside of those areas. But it all only works if that marine protected area is there and we have fish that are in a safe area where they're not going to be taken out. And in this way, we can ensure that we have sustainable fisheries. And at the same time, protecting areas of sensitive environments, which we need to do in order for our oceans to be able to continue to function the way they should function. So science and research are important for us to monitor and learn about the impacts of what we're doing. For example, in order to protect and manage fisheries sustainably, scientists need to collect data on the targeted species to assist in the management of the fish and the environment. So things that they look at is, what is the fish? What does that fish eat? Does it change sex as it gets older? Is it a rudimentary hermaphrodite? Is it a protogeny or protandry? In other words, change from female to male or male to female as they develop. And at what age do they do that? Because by knowing all that information, we can then say, right, we can't catch these fish unless they're this size, because by that time they've gone through their sex changes and they've bred. And obviously, if we have them females, we need the females to be as large as possible, because the larger a female fish is, the greater the number of eggs she develops. So we work on something called BOF, big, old, fat, fertile, fecund fish. So the older they are, the more eggs they produce. Okay, and then the other thing that they do when they're gathering data on the fish is they take the otolith out, which is the ear bone, and that has rings on it, growth rings. And that allows the scientists then to work out how old the fish was. And through that, they can put all that data together and they can work out things like bag limits, size limits, how many we can take out, quotas and stuff like that, so that that fishery can be managed sustainably. And in that way, we can manage the fish and the environment without or reducing our impact on them. So what can we do? There are a number of things that we can do. We can refuse to take single-use plastics. We can reduce the amount of single-use plastics we use. We can reuse things. We can recycle. We can become conscious consumers, which is asking, where does this food come from? How was it cultivated or farmed or caught? What impact is there on the environment through this production? Now, there's a saying that says every drop counts, but you often feel that what you're doing to mitigate or combat something as overwhelming as climate change is just a drop in the ocean. But think of it this way. What if there were no drops in the ocean? Thank you, everybody.
Fantastic. Thank you so much, Kathy. That was really fascinating. And especially loved how much you ended on hope at the end. Obviously, as conservationists, a lot of us come across the negative impacts of humans, as you demonstrated earlier in the presentation, but it's nice to end on a note of hope and know what we can do to make a difference. I know that personally, sometimes it does feel overwhelming every day trying to tackle this big problem, but if everybody did their own little bit, then it wouldn't be such a problem. Many hands make light work, as they say. Does anyone in the audience have any questions? I thought, oh, there we go, Alyssa. Go for it.
Yeah, first of all, thank you a lot for that really, broad but also in-depth presentation, Kathy. And a lot of it was actually also relevant, I feel, for Namibia, the Namibian coast. I think, but unfortunately, even though we have such a long coastline, a very few of our population stays on the coast because it's a desert. It's on the west coast. However, I do see some of our teachers in the audience, and I'm really glad they made it, like so Tresia, and it's the only name I recognize, but I think there are a few other teachers as well. And they are so they stay in the north of Namibia, and I think most of them are in the north of Namibia or in the inland. And so I think a very simple question that I have is, what would be your, you could say, what is the take-home message to teachers who are teaching, not at the coast, but inland? How can they explain what is the importance of the ocean to all of us, even though we stay so far from it? That's my question.
Okay. I think one of the easiest or the main areas that is where it fits into the water cycle, in that it is where most of the water is stored. And if anything happens to the ocean, it will have an impact to life. And that doesn't mean it's only what happens in the ocean. but it's what happens inland, because everything that happens inland is influenced by through the water cycle, or the water cycle impacts on that. So that's if you are, say you are farming and you spray pesticides on your crops, and the rain comes and it washes it, it's leached down into the soil and it ends up making its way into the ocean. That's going to have an impact on the ocean. Food, if depending on what type of, if they eat fish, where does that fish come from? And looking at what that fish needs in order to survive, would, I think, could also help with bringing that message across. I'm trying to think. One of the biggest things that we do in our outreach program is focusing on catchments, and how it doesn't matter where you are along the catchment. Whatever you do there has some form of impact as you move down that catchment towards the coast. I'm just trying to think of some other ways. Climate might also, looking at the climate and the impact that the ocean has on the climate around the area. So we're not looking at weather patterns as such, but the overall climate. And if that changes, then the climate changes.
So I don't know how much you know about, I mean, I know you focus on marine education, but say, for example, now, I mean, so that's my understanding, is that if our oceans are warming, that ocean conveyor belt that you spoke about in the beginning, it's going to slow down, or is it just going to be warmer?
It's
and
going to.
what could that mean for Namibia's coastline now, specifically with our cold Benguela upwelling?
So it's going to, that ocean conveyor is going to slow down as the polar regions get warmer because of the increased water temperature, and ultimately that conveyor belt could end up stopping. It's not something that's going to happen immediately. It's going to take more than 1,000 odd years for that to happen, hopefully. But what impact that will have on the Namibian coastline is that instead of having that nice cold water coming up and that upwelling, cold deep water upwelling, that's going to start reducing, which means that your fish stocks are going to start reducing in number, because there's that area is no longer as productive, because you're not getting the same cold rich nutrient-rich water coming up, which allows for the productivity of the photosynthesis of your plankton, which the fish around up the coastline feed on. So that's the impact that it would end up having. It's not going to be an immediate one, but you will start seeing impacts of that. Now, we have done in South Africa, where with our sardine run, our sardines, other than being overfished, we find that the sardine run, at times, some years, it's much smaller than it used to be. And the only thing that we can put to it is that because the waters are getting warmer and the little wedge of cold water trying to push up between the coastline and the Ogalus Current is not as cold as it used to be. So it can't push as far up. And as a result of that, then fish are moving further out. The sardine run is still happening, but it's happening further out at sea because the water's colder out there.
Okay. I have a follow-up question, but I think I first want to give other people a chance to ask as well.
Well, I don't see any hands up, Alyssa, so if you'd like to ask your follow-up question, we've got a few minutes, so please do go for it.
Okay, I think my question is still on the changing of the Benguela, and you spoke about the changes in fish, the productivity of the ocean, but because I think we've got predictions that the the desert or Namibia in general is going to become warmer in terms of our climate and our weather, and it's going to become rainfall is going to become less, but also more scattered. I just wonder if it's because I know you are in Durban, it's a warmer ocean there, and it's more humid, I think.
Yeah.
How does a warming ocean change? Could it change our climate? Would it exacerbate even more of the heat? Like to increase the heat, or would it maybe make it more moist? I don't know if you understand that question.
Okay. So I'm not a climate change person as such, but what I have read is that the West Coast will become hotter, as you said, with more sporadic rain, while the East Coast will become even more hot and a lot more rain. So we will literally end up getting to a point where we are having constant rain. We no longer have this nice kind of temperate environment that we have, subtropical environment we have. It's going to become far more tropical. And when we have our rainy seasons and when our main rainy season stuff is going to shift. So it's going to move earlier or later, depending on what changes there are. So in our area, it will move forward or it will move back. We'll have our summer will start a lot earlier. And on the West Coast, it will move forward. So instead of your summer would start a bit later, but you'd have a summer, so to say. I don't know if that makes sense.
Yeah, a little bit. I'm also not a climate scientist.
It's actually extremely complicated, and trying to understand everything is very difficult. I know already in the what I've read in the United States is that the growing seasons for a number of crops have changed over there because of due to climate change, due to change in rainfall. So they're having to adapt their planting seasons in order to accommodate the change in climate. And if you don't make those adaptations, the farmers are losing out or missing out on the window that they have for production. And yeah, over there, they seem to be butting their heads against a lot of people who reckon climate change isn't something to worry about. It's just a figment of your imagination. But the farmers on the ground are saying it's very real because they've noticed this change in the seasons when the seasons are starting. So we would end up experiencing similar things. The areas where they've already noticed this are areas much sort of in the central United States, central and southern side of the United States. So it's something that we can expect would start happening within Southern Africa going forward.
I mean, it's not been proven, but we already have seen a shift in our rainfall. Especially in the north of Namibia, we rely on the summer rainfall, and it's come later or it's more sporadic. So yeah, adapting is important. Yeah. Thank you.
Great, thank you so much. Thank you for all of those questions, Alyssa. That was a really fascinating discussion. And I think we ended it on a perfect note, which is that adaptability, I think that's really going to determine how well the world does in the future, but also humans. I think we all need to adapt our behaviors quite drastically to be able to sort of slow the progress of all of the damage and destruction that we're causing. But hopefully there's a lot of like-minded, passionate people like the people who come to these talks and experts like you, Kathy, and I hope that, yeah, we can do it. And that is pretty much us on the hour. So thank you so much, Kathy, for your time. Really, really fascinating talk.
Yeah.
Thank you everyone in the audience as well for joining. Thank you for your wonderful questions, Alyssa. This talk will be available in a couple of weeks on our Share Screen Africa website. Kathy, I'll share the link with you directly, and you'll be free to share it with your network as well. And for anyone else who'd like to rewatch it or catch up on it, it'll be available then. So thank you very much, and I hope you both have I hope everyone has a really wonderful evening.
Thank you.
Bye. Thank you.
Bye.
Great. Thanks, everyone.